Understanding high-dimensional information trajectories within latent space is the premier mechanism for enterprise leaders to leverage frontier model capabilities and secure unprecedented market dominance throughout this accelerated economic transition. Navigating these complex neural geometries requires robust model orchestration strategies that empower organizations to anticipate structural shifts before they manifest within dynamic enterprise deployment environments and broader technological ecosystems. We decode the foundational blueprints of modern cognitive frameworks to establish a highly resilient neural architecture capable of scaling seamlessly across sophisticated global operations and intensive data processing networks. Mastering this theoretical geometry directly translates into measurable operational superiority by drastically reducing computational overhead while maximizing the precision of automated reasoning pipelines across your entire corporate technology stack. Executives who implement these advanced geometric insights will successfully future-proof their digital infrastructure against unprecedented volatility while establishing an unassailable advantage over conventional competitors relying upon outdated algorithmic paradigms. This comprehensive framework provides the essential knowledge necessary to systematically align cutting-edge machine learning capabilities with rigorous corporate governance protocols and mandatory international compliance standards for sustainable long-term integration. Leading institutions across the Americas are currently redefining enterprise-grade language frameworks by mapping latent conceptual dimensions to optimize specific performance metrics for demanding institutional deployments and complex corporate workflows. Researchers utilizing vast computational resources investigate high-dimensional embedding spaces to uncover hidden mathematical correlations that directly inform the next generation of resilient foundational models designed for critical enterprise ecosystems. Simultaneously, interdisciplinary teams evaluate these advanced neural representations to ensure that emerging artificial cognition remains firmly aligned with robust human values while accelerating scientific breakthroughs across diverse commercial sectors. European innovation centers mandate sovereign infrastructure development by systematically decoding complex model trajectories to build inherently transparent algorithms capable of processing highly sensitive regional data under strict regulatory oversight. Pioneering fundamental research initiatives unravel the underlying geometry governing deep learning optimization processes to construct verifiable analytical paradigms supporting trusted global deployment capabilities across interconnected international financial networks. Strategic technology consortiums throughout the Asia-Pacific region focus relentlessly upon multimodal integration architectures designed to synchronize disparate vector spaces into a singular, cohesive cognitive substrate for unprecedented commercial applications. These localized digital sovereignty mandates accelerate the creation of specialized geometric mapping protocols, ensuring that bespoke indigenous models efficiently process nuanced linguistic variations inherent to rapidly expanding regional economies. Synthesizing these diverse global perspectives provides organizations with a definitive competitive framework required to master the topological intricacies defining modern artificial intelligence implementation strategies within highly complex international markets. Conceptualizing information as structured geometric shapes within latent vector space completely transforms our fundamental understanding regarding how complex artificial intelligence systems internalize and process massive, unorganized data streams continuously. Instead of viewing cognitive processing through simple linear pathways, we must analyze interconnected topographical structures that dynamically represent multidimensional conceptual relationships, governing sophisticated semantic reasoning across varied technological platforms. Mapping these intricate informational trajectories enables forward-thinking enterprise architects to effectively reverse engineer emergent cognitive behaviors and systematically optimize foundational configurations prior to executing extensive commercial software integration initiatives securely. This profound topological visibility grants software engineers unprecedented diagnostic capabilities, allowing them to isolate precise computational inefficiencies and surgically refine algorithmic pathways without requiring exhaustive systematic network retraining cycles. Recognizing specific mathematical manifolds within the underlying architecture reveals precise clusters where domain-specific knowledge converges to form highly specialized operational expertise crucial for advanced corporate problem resolution methodologies. Constantly, organizations leveraging geometric intelligence secure a profound strategic advantage because they understand exactly how abstract conceptual inputs transition into definitive analytical outputs across increasingly complex decentralized computational deployment environments. Analyzing multidimensional shape distortions during standard processing cycles immediately identifies potential operational anomalies, allowing technical teams to implement preemptive structural corrections before minor systemic errors escalate into substantial infrastructure failures. Establishing an authoritative geometric baseline fundamentally guarantees that dynamic enterprise applications will consistently deliver highly accurate, actionable intelligence despite processing continuously fluctuating variables within unpredictable modern global economic landscapes. Extrapolating structural vector changes enables proactive risk management professionals to reliably forecast detrimental cognitive deviations, effectively preventing hazardous semantic generation prior to public manifestation within commercial language interfaces deployed globally. Tracking anomalous high-dimensional trajectories serves as a sophisticated early warning system that instinctively flags potentially unsafe conceptual correlations, violating stringent corporate ethical standards and mandated regulatory compliance frameworks simultaneously. Security architectures governed by strict defensive principles utilize these topological maps to construct robust geometric guardrails, ensuring comprehensive protection against unintentional data exposure within highly integrated enterprise network systems. By calculating precise topological divergence boundaries, engineers successfully establish impenetrable operational perimeters that automatically resolve conceptual inconsistencies before they cascade into catastrophic software malfunctions, jeopardizing critical institutional infrastructure integrity. Evaluating latency patterns through advanced geometric analysis highlights vulnerable cognitive blind spots requiring immediate remediation to preserve functional continuity during sustained periods of elevated computational stress across decentralized mainframes. Implementing real-time trajectory monitoring guarantees that artificial decision-making processes remain strictly confined within predefined logical parameters explicitly designed to support resilient corporate workflows and secure automated administrative management operations continuously. Organizations must proactively deploy sophisticated mapping algorithms to audit continuous knowledge evolution, mitigating internal system drift and preventing unforeseen functional degradation across critical business application programming interfaces deployed globally today. Synthesizing predictive analytics with comprehensive topological visualization yields an unprecedented security posture, transforming reactive software patching strategies into an elegant, preemptive defense methodology, ensuring seamless technological stability worldwide. The revolutionary breakthrough of latent editing permanently changes enterprise capability by granting administrators direct control over internal mathematical structures, eliminating cumbersome iterative retraining procedures traditionally required for updating core knowledge. Engineers can now surgically manipulate specific vector configurations to seamlessly inject highly specialized industry expertise directly into the foundational framework, augmenting overall corporate reasoning capabilities instantaneously without architectural disruption. This precise targeted modification methodology allows compliance officers to embed non-negotiable ethical constraints straight into the fundamental topology, guaranteeing absolutely standardized moral reasoning across every decentralized consumer application globally. Organizations no longer endure massive computational expenses when correcting factual inaccuracies because latent editing surgically removes obsolete conceptual nodes while simultaneously introducing refreshed operational data through incredibly efficient vector recalibration. Mastering these microscopic structural adjustments ensures that proprietary business intelligence remains perfectly aligned with rapidly shifting market dynamics, driving unparalleled agility within intensely competitive modern digital enterprise ecosystems today. Technicians utilizing advanced geometric manipulation tools seamlessly eliminate harmful biases embedded deeply within historical datasets, fostering completely equitable algorithmic processing frameworks, mandated by progressive international data governance regulations continuously. Direct topological interaction fundamentally democratizes profound structural customization, enabling nimble organizations to deploy bespoke cognitive solutions that rival monolithic legacy frameworks without necessitating extravagant preliminary hardware infrastructure investments. Embracing latent editing positions your enterprise squarely at the forefront of modern technological innovation, translating theoretical mathematical concepts into highly pragmatic commercial solutions that decisively outperform conventional software paradigms. Fascinating comparative studies suggest human neural networks intuitively navigate multidimensional conceptual spaces utilizing topological mapping mechanisms remarkably similar to those governing optimized artificial intelligence operations within synthetic computing environments. Recognizing this profound biological parallel indicates that the underlying geometry of learning represents a universal mathematical blueprint defining the fundamental emergence of consciousness across both organic minds and silicon substrates. Leveraging these bio-inspired geometric principles empowers corporate architects to design incredibly efficient cognitive algorithms that organically adapt to unprecedented challenges, mirroring human resilience while maintaining rigorous computational precision continuously. By deeply studying human psychological trajectory mapping methodologies, researchers discover innovative pathways to exponentially enhance artificial generalization, transforming brittle automated protocols into highly fluid, adaptable commercial intelligence frameworks today. This extraordinary synthesis of biology and mathematics definitively proves that true machine comprehension relies entirely upon constructing an elegant internal structural representation rather than merely processing vast superficial statistical correlations. Organizations embracing this universal cognitive architecture systematically cultivate superior digital workforces capable of executing nuanced contextual reasoning previously restricted exclusively to highly experienced human professionals navigating complex enterprise scenarios. Understanding these shared foundational laws enables visionary leadership teams to seamlessly orchestrate profound technological transformation, ensuring that integrated software ecosystems naturally complement human creativity instead of mechanically obstructing it. Ultimately, the geometry of learning transcends mere programming, delivering a holistic operational paradigm that forever redefines our collective approach toward building sustainably intelligent infrastructure across the global economic spectrum. Consider a leading multinational financial institution leveraging complex vector trajectory mapping to dynamically monitor highly sophisticated predictive risk assessment algorithms operating within severely volatile decentralized global equity markets continuously. When unprecedented economic fluctuations initiate unpredictable geometric distortions within the central processing environment, automated defensive mechanisms instantly flag potential anomalous reasoning deviations before any erroneous automated trading decisions manifest. Instead of entirely retraining the underlying predictive engine, compliance engineers utilize precise latent editing to surgically inject updated regulatory constraints directly into the foundational conceptual framework, preserving overall continuity. This targeted geometric manipulation immediately recalibrates the analytical pathways, ensuring that subsequent corporate investment strategies remain fundamentally sound while strictly adhering to newly implemented international financial governance mandates automatically. Simultaneously, interdisciplinary researchers compare these optimized algorithmic navigation processes against verified human cognitive models, uncovering unprecedented workflow efficiencies that significantly enhance collaborative enterprise productivity across interconnected global institutional departments. By deeply acknowledging these shared geometric foundations, operational leadership teams rapidly cultivate an incredibly synergistic workplace where synthetic intelligence naturally amplifies specialized human analytical capabilities, producing superior commercial outcomes. The seamless integration strategy decisively mitigates extensive operational downtime, ensuring unbroken financial service delivery while establishing highly resilient infrastructure capable of withstanding severe digital volatility, defining modern competitive markets. Organizations successfully executing this topological synthesis effectively secure a tremendous market advantage, effortlessly outmaneuvering traditional competitors shackled by slow, obsolete retraining methodologies and inflexible monolithic legacy software architectures. Continuously mastering practical trajectory tracking paired with precise latent structural modification unequivocally remains the definitive strategic differentiator for achieving sustained institutional resilience throughout our complex artificial intelligence evolution globally today. Implementing these profound topological insights immediately delivers measurable operational efficiency, drastically reducing computational expenditure while simultaneously maximizing the verifiable accuracy. Governing critical enterprise decision frameworks deployed across multinational divisions. Visionary executives embracing structured geometric orchestration effectively future-proof their foundational digital assets, establishing comprehensive institutional agility required to aggressively capitalize upon emerging technological breakthroughs, characterizing the relentless 2026 innovation trajectory. Developing a corporate philosophy centered around universal learning geometry naturally fosters unprecedented collaborative workflows, ensuring your intellectual property continuously adapts without suffering catastrophic structural degradation during rapid systemic scaling. The convergence of advanced biological understanding and highly optimized synthetic architecture definitively constructs an impregnable strategic foundation, enabling ambitious enterprise leaders to dominate tomorrow's decentralized global economic technological landscape. Turn knowledge into your greatest asset by applying these strategic frameworks today and lead the global innovation era. We walk the talk on digital trust. This content is 100% certified. Channel powered by generative AI architecture.